Okay, let's look at one last but important system of equations example. Taking a look at the system that I have written here, 3x minus 2y is equal to negative 2, and negative 6x plus 4y is equal to 1, we can see that the best way to solve this system is going to be by using the elimination method, because it's not so clear-cut how to get one of these variables by themselves in order to use substitution. So we're going to take a look at this first equation, and I see that if I multiply it by a 2 here, that's going to give me a positive 6 as a coefficient, and then we'll have two opposite coefficients, which is great. So my first equation becomes 6x minus 4y is equal to negative 4. And my second equation stays the way it is. It says negative 6x plus 4y is equal to 1. Great. So now we can go ahead and we can add the two equations together. But this is how this example is different from most other examples that you see, and that is when you go to add the equations together, the x's disappear, but the y's also disappear, leaving you with 0 is equal to negative 3. So the question becomes, how do I find a solution if my x's and my y's both disappear? Well, the fact that we have 0 equals negative 3 tells us something very important, because we know that 0 never equals negative 3, and so this ultimately gives me a false statement. And a false statement always means that there is no solution. So when your x's and y's disappear, if you get a false statement, you end up with no solution. Now, here's the thing. You can't always assume that when your x's and y's disappear that you end up with no solution, because let's say we had the following example. Let's say we had an example where, I don't know, we ended up with something that looked like negative 6x plus 4y is equal to 2, and 6x minus 4y is equal to negative 2. In that case, when the x's and the y's disappear, so do the constants on the right-hand side, and we would end up with 0 is equal to 0. Now, 0 is equal to 0 is not a false statement. That is a true statement. And a true statement always indicates that it is an identity and there are infinite solutions. So you really have to be careful. Do not just make the assumption that because your x and y disappeared, well, first of all, don't make the assumption that you've done something wrong. That doesn't mean you've done something wrong. And don't make the assumption that it's always going to be no solution. It will depend on whether or not you end up with a statement like this that makes no sense, and then it implies that it's no solution, or a statement like this that is perfectly true, which implies that there are infinite solutions.